Hello, good afternoon everyone. Welcome to my first part of the three-part video called how to actually generate my heat map from my CSV easily using R. And we want to do some hierarchical clustering on the data as well. So for first thing first, this is not meant for experts. So if you're an expert in R watching this, I'm sure you're gonna cringe really hard and something is gonna explode. So I'm just gonna try to introduce this language and this methodology to beginners. So I'll try to avoid as much technical language as I can. And the context of this video is gonna how to actually plot gene expression data from large experiments such as microarray or RNA sequencing. So of course, if you have human data, they're gonna interpret slightly differently and there'll be slightly different workflow. But if you have the similar data structure that we have, you can actually model the whole the script pipeline and just generate your graph very easily from the script that I've written, or I actually copy paste from many other websites just to put together and make it work. Okay, so before I start wasting any time again, the first thing you need to install here is actually R. So if you don't know, R is actually a programming language that actually designed around this data analysis and data integration and just designed there to handle the statistic around big data. So of course, it is not a very easy to use version because it is open source. It's actually built and maintained by volunteers, and it's slightly more messy than the very sophisticated, let's say, Excel or Adobe Premiere that you are working with. So it's a command line interface, so you have to interact with the software with things typed on the computer. However, it's actually not as difficult as it seems compared to other programming language that I've been through. So there are two things you need to download. The first one is actually the R package. So you just can type R package download. It should bring you directly there. So luckily it doesn't start with P, otherwise it's gonna be a very awkward situation sharing my search history with the internet. Okay, so R package download, this will contain the source code and the background architecture infrastructure you need for the R programming. So this is just a source code. But for us to interact with R, I'll prefer to actually run everything in RStudio. Yes, you can run R inside a command line interface. You can run it in PowerShell even. But usually I use RStudio because it's a lot easier to interact with. You can see a lot more things and it's a lot more intuitive for people that have never done programming or command line interface interaction before. So it can actually help a lot of people to get an idea of how it works before they upgrade to their command interface. So these are the two things you need to download. If you have Windows, you can use 3.5, and if you're not, you might need to use 3.4 for R. RStudio, just download whatever that's newer, and then you just open it up like a normal program. I'm going to teach you how to install program over here. So once you open up RStudio, it's going to look somewhat like this. Okay, you have a console, you have an environment, you have a plot. So today, I'm not going to type everything from ground up because that would take a lot of time. So the first video, I'm just going to show you how to do the data preparation. Basically, how to import your CSV into R. And yes, that's one video because it's kind of complicated for the computer to understand a lot of things, which is why I say R is slightly more messy. Okay, so R has something called R scripts. So this R script is just a file with extension of just R, just one small R in the end. This is basically just a TXT file, and yes, you can actually just save a TXT as an R file, and otherwise, reversible is fine. So what this contains is just a bunch of command line for you to actually generate your code. So you can actually run this over and over again without typing it in one by one every time. So what you can do is that once you have this TXT file you're ready, just type it to R and then you are able to open it into RStudio. So what you do is to double click on this and you can open with RStudio. If we go back to RStudio over here, you'll see that your code will appear on the top left corner. So this is all the code that you need for today and actually to work on this project. And this is actually a fairly small code, only 66 different lines. Very nice language. I should put it to 69. Let's put it to 69. Now we got 69 over there. Okay, so first thing first, you need your data ready. Okay, so in this case, I'm not gonna use R because it's a relatively more data size. So in this case, I'm just going to use Excel to open and manipulate my CSV file. So in a very typical RNA-Seq structure, you have sample A, B, C, D, E. Let's say you have 5 samples over here. So you want to actually observe what are the trending changes in between them. Then you have about 5,612 gene over here. And then what we can do here is to try to generate a random data, shall we? So in Excel, you can just do random between. Let's say the gene expression or TPM, RPKM is around 5,000. Okay, you can run a random between 1 to 5,000. And then you are able to just copy paste the whole thing and okay, done. So now you have a bunch of random data which is random from 1 to 5,000. In this case, this will be a representation of your RNA-Seq TPM, RPKM, or FPKM, depends on the situation that you have and the condition you're in and what do you prefer to run on. Okay, in this case, in a gene expression data, gene will never be that even. So one of the data might be like super duper big, let's say 10 million. Let's say there's a few of them. And it's very common for RNA-Seq data to have something like ridiculously big and something ridiculously small, let's say 0.01. And yes, your statistical test might, if you are using, let's say, a DEG analysis before this, you might be able to fish all this thing out, or they might amplify them because the changes in between sample are so big. So usually in the RNA-Seq workflow, you have a lot of weird data around inside your plots. Okay, so this can be done in Excel, and once you have your data in Excel over here, which I believe you can ask from your service provider, or you can actually take this out from the DSEC2 program or HR, depends on what you're using it. You can just save as desktop over here and just save as this comma delimited format. Okay, so it's important to save as CSV because yes, RStudio can actually open what you call an Excel format, but it's slightly more janky, and I believe CSV is a way easier way to go forward, especially if you're not using Microsoft Office. Let's say you have an open office, you have some other spreadsheet format, Google Sheet. Let's say you want to download the data down. CSV is a more open format where everyone don't have to pay. So upon saving, they'll ask you some feature might be lost if you save as a CSV. Go ahead and click yes, no problem, because when you actually save as a CSV and you open it up again, your equation is gone. Okay, so all you left is the numbers that we have typed in just now. Okay, so in this case, go ahead and close it. Now you're done. So remember that you have to save this at your desktop, and you actually go forward and look at your path, which is here. Okay, so it's under this location. Because my name is Brandon, obviously everybody knows that. My path is under user, Brandon, and desktop. So yours might vary a little bit here and there. Okay, so remember this, then we can go back to R and try to import our data in now. Okay, in this case, once we go back to R, before we start doing anything, I think let's just try to import let's just try to read our CSV first, isn't it? So before I try to read our CSV, you can see over here, remember the location that we have just now? So you try to put the file name together with the location on here. So try to replace this with the location on your computer, otherwise it will not work on here. So once you're done, leave it there. We're going to import it soon. But before we start importing, I have to introduce something called what is a workspace. So workspace, as you can see here for the first text right on top left corner, the first line on my script is called clear workspace. So the meaning of clear workspace is that I want to clear off everything I have in this R environment. You can see there's an environment up here. So I want to actually remove the environment so that we do not have any leftover data from your last session. We don't have any length left over so that it might interfere with what we do. So what we do in R is that we use a RM, which is remove, list equals to list, so that it will clear everything you have in your current workspace. And if you have any important save somewhere around in R, try to be careful because when you run this, everything is gone. So in R, how you actually run a script is that you can see there's a script here. So this is the file that we open. So you highlight the script, and then there's a run button. You just click the run button, and it will run on your console. Okay. So in this case, of course, we have nothing. So this will actually clear everything that we have but we have nothing to begin with, so that's fine. So this is not that important. So the second thing we have is called a library import. So library in R is sort of like your app store in your iPhone or your Android market in your Google, or they call it Play Store now or something. So yeah, you know how old I am now. Okay, in this case, a library is kind of like an additional add-on to your RStudio or your R package. So initially, maybe you can't do a lot of amazing plot, so that you install another new app called gplot. In this case, this gplot is it's a different name. They don't call it app, they call it library. So in this library, there will be many tools, many software functions, actually not software, more like a function for you to be able to do more things with your R. Same with tidyverse, same with clusters, same with factor extra. So how to install the library will be here. So you go to your tools, install packages, and you go and retrieve package installation context, and this will be a lot slower if you have a very slow internet connection like me, or your some roommate is watching Netflix or whatever. So in this case, you have an install package from repository, which is a place, is a library where you put your library. Okay, so you just type in the 4 things that we have over here. So you can see there's 4 library that we need for this exercise. So you just type in gplot and you press install. Very simple, and you will run the thing by itself. Okay, so everything that is running currently will be represented by the console down here, and all the script will be on top in the R script place. And environment and plot, I'm going to show you later how it works. Okay, so once we are done, we install all 4 of them. I'm not going to install here on camera because it takes a long time. So what we do is that we highlight the thing that we want to run, and we just play it. No, we don't want to remove the workspace again. We just press run. So in this case, it will run through all 4 of the library, and you can check through all the output in the console window here. This is fine, this is under steady state, this is attaching package, and there's no conflict. Yeah, that's fine. And you have this is normal, and you have this factor extra, no problem, cluster, no problem. So there's no problem installing a certain library in your computer. And you have a problem, try to reinstall again, or you try to find a package that is actually the same version as your R, but if you are installing based on the thing that we have over here, you will not have any problem. So once you install all the library, finally we can start to export our data. So there are a few ways to do this. And one of the way, if you are not familiar with coding, is that you can actually directly click this button here. So this actually open an external file, and you can just click your file which is on the desktop. Okay, so you can just click it here. It should just open as well. Okay, but you see there's some problem. So when they load, they're unable to load because there's some problem, because sometimes because some encoding problem, R is unable to load the file directly. So if you actually see, even though there's an error here, we go out and we open this file again, it's perfectly fine. It looks perfectly normal. So what we have to do here is use this command. So this is a read CSV command. So read CSV, very obviously, they'll read a CSV file from your computer into this R environment. So what does this do? Very simple. You put your directory over here. The separation is the separation in between your data. In this case, it's a comma delimited file. So the separation will be a comma. So what you do, you just run this command. You realize that it's done. Very simple, very perfect. So in this case, the imported file is stored as LC. So LC is what we call a variable. And when we run this command, what they do is to take this file and throw it into LC. Okay, so you can see the arrow here. The arrow means assign to this variable. So once you run this CSV, the LC variable now will contains the data matrix that we generated in the CSV just now. So just in case you are worried that you cannot see your data, you actually can see it here. So just click on this, they will actually show you this nicely generated data that we have just now. Okay, we have your gene, we have your simple A, B, C, D, E, and all the expression level. However, now it's slightly more difficult and slightly more problematic, because you realize the first column is actually a text and the rest of the column is just numbers. And in R, they do not like that, because this is now there are different format in the same thing. LC now is actually what we call a data frame. So a data frame contains multiple multiple different type of data. And when we actually try to run a data frame downstream, we're usually having a little bit more problem because certain package, certain function do not understand how to differentiate between a text and a number, and then when they run into error, they just go panic and they don't run at all, and you run to error that you have no idea how to solve. So we're just gonna do a little bit of things, try to eliminate that, and try to put this data into a very nice format that we can use for our downstream analysis. So the first thing we have to do is this. So this is an order function. So what does this do is to order based on the sample A. So I'm gonna reorder the whole thing based on the second column over here, which is the column A. Very simple, run this command very fast. So now you can see if you scroll all the way up, so A will be from the smallest to the largest. So this step is not critically important. It's not going to affect any of the calculation in the back, but I usually run it so that I can be able to understand how it works, and just to make sure that I'm running on the right data set and stuff before I start messing around with it. So the second we have to do is to assign what we have is gene name over here onto the row name, because we do not want them in the data matrix, and also we do not want to lose this data set. Okay, you might say, hey, this gene number is the same as row number, I don't have to do anything with it. And you are right. If your gene number is exactly as your row number, that's fine, but most of the time, this will not call gene 4377. This will be called transcript 654C.2, then you have your underscore 625 nano NT, because you have that amount of nucleotide or whatever. So it will not be a nicely ordered manner. So in this case, if you're assigned to your row, later you're able to see your transcript in your analysis directly. So what we do on the second command here is to assign the column X as the row name. So you can see this actually is a column X because we do not give them anything. So they automatically assign a random alphabet to that. Okay, so let's just run this command. Very fast, very easy. So we go back to our data set. You can see that all the gene has been assigned with their name. So now we have assigned with their name, we can get rid of the first column because we do not want any text within our spreadsheet over here. So what we do is to run this command. So this command is very, very simple. You can see this is row 1. So this is row 1 to row 5612. If you scroll all the way down, there's only 5612 entries. So we want to include every row. So if you do not want a certain row, you can also remove certain things. That's why we have an ordering over here. So if you want to exclude all the super big data in A, you can exclude this one. So if that's what you want, of course. And this, so once we're done with the row, here is the column. So in this case, the -1 indicate that we do not want the first row. And we do not want the first column. We want to keep the rest of the column, which is column 2, 3, 4, 5, 6 over here. So this -1 is actually the same as 2 to 6. But just for simplicity's sake, because when you type more, you get more errors, I'm just going to put -1. So what does this do? Is to keep every single row except the first column. I'm going to remove the first column. So let's run this command. You can see it's done running here. And you can see the first row is gone. So now we are left with a bunch of numbers. So everything here is in numbers. Much easier. Now we can start our calculations on everything that we need to. Okay, so the first thing that we need to do before we start calculation is to transform this whole thing into a data matrix. Because just now, remember, we have imported some text, so the computer might be a little bit more confused on how to actually process all this information. So the next here we call LC data matrix LC is actually take this data frame actually and force it into a matrix. So if you don't know, a matrix inside R is just a matrix basically. So it's a spreadsheet with only a single type of variable. In this case, they'll force everything into a numbers. Okay, so you can also use S.matrix or data matrix, doesn't really matter. In this case, it's slightly simple because there's not really a lot of weird data point inside there because we just generated randomly ourselves. And if you have a third party to give the data set to you, sometimes you have to check for, maybe some people just put a NA inside there and you will run into an error when you do this kind of command. Okay, so let's just run this and we can actually force everything into a matrix. You can see here, it become a large matrix over here. 26060 elements and 600 kilobyte. are actually very, very small in comparison to other data set that I work with. They're usually in megabytes, on a few hundred megabytes sometimes. So now we actually can see it doesn't change at all, but the computer has now registered this whole thing as data matrix, which is that everything here is numeric, everything here is numbers. I'm gonna treat that as a number, so when you are doing plus, minus, and whatever calculation is a lot easier, which is what exactly we're gonna do next. So the next thing we have to do is called a log transformation. So a log transformation is to actually normalize the big data we have just now. So in this case, we can actually try to plot this in, let's say the first and second column. Okay, shall we? So LC B. So in this case, plot operator is invariant for atomic vectors. Never mind, let's just plot LC and LC. Sorry. No, I don't want to do that. Just one will do. Okay, so you can see here, this is actually plotting A and B. You don't have to do all of this, what I've just done. So in this case, you can see there's one big data point here. And that big data point is not a coincidence, it's not chance. It's actually one of the data points that were planted in B, if I believe. So you can actually sort this here. You can see B has a 1 million data point. So in this case, this is so big and it's going to interfere with our data, because when one data is super big, you can't actually visualize the rest of them very easily. So what we have to do here is called log transformation. Log transformation, very simple. You just log 10 every single value in your matrix. So in this case, you have to put a +1 because there's some zero value there. If you have a 0, when you have a log 10 0, it will become infinite. They'll cause you an error. So what we do is to plus every single number within the expression value by 1. So once you plus that, 1 log 10 of the value 1 will be equals to 0. Okay, so log 10 0 1 is going to equals to 0, so that's going to regenerate our 0 value, so that's not an issue. So in this case, how to run log 10? Very simple, just copy this command again and run again. So in this case, every single thing will be normalized. So if we plot our graph again, you can see it's still the same. Something is wrong. Oh, sorry, log LC. So if we plot our graph again after log transformation, you realize that everything is a lot more normalized. You can actually see all the data value coming out of the shadow just now. Okay, but now the mean here is still in the middle. So in data science, we have something called scaling. So what do we want to actually scale it? So what's the meaning of scaling is that you are transforming the mean into 0. So everything will be from let's say -3 to +3. So the middle point, the mean of all the data will be a 0, and I think it'll be easier if I just demonstrate the whole thing. So once we're done that, you can actually see here, your data will be, so this is your raw data, which looks somewhat like that. They are all whole numbers. And once you log that, you would realize that everything is a lot smaller and a lot closer together. Even your biggest and smallest value just now, remember we have a 10 million in sample B, it's now become a 7. So they are a lot closer together, a lot more visualized, and a lot easier to work with in general. Okay, so in this case, what we're going to do is to actually run a scaling. So once we have scale and normalized data, so it will look somewhat like that. So everything will have, instead of just 0 to 7 or 1 to 7, we will actually have negative value. So you can actually see this one is still, the largest value of B is actually now -7 to 8.4. So that would actually make it a lot easier to understand, because when you see a 0, that actually represents a 0 value. So that is the midpoint. So if you want, you can just plot it out again, and let's have a look. Okay, now you see, now everything in the middle is a 0, and everything will spread from the negative to the positive 0 on that side. And there's some more data on air on the other side, but let's not care about that for now, because that's not very important. So once you've done that, we usually transfer the whole data that we had into a different value, because in this case I choose a Y because this is what the other guys are doing in their blog and do not want to modify their file based on my value. So I can actually just transform what I have generated just now, which is LSC, which is scale LC, normal value. So this is the normalized value into the variable Y, because everything here underneath is going to be run into Y. So let's just run the last command. And done. So basically you are done for the first part. So just a short summary of what we have done just now. You have actually installed R, and you have installed this nice RStudio. You have cleared all your workspace so that you don't have residue that might interfere your work later. You have imported and installed 4 libraries so that you make sure you are able to plot anything you want later, and you are able to use the function you need and they will not run into an errors. So after you input the 4 information, what you have to do is that you put your raw CSV on your desktop or anywhere that you prefer. Look at where is the location. Remember, Windows will have a backward slash. In R, you have a forward slash. Just remember that, okay? Otherwise, you run into an error again. So just look at where is it, and you put it into this string of text right here. Remember to keep the double quote, because you have to have the double quote, otherwise it won't work. Just put your location here, put your file name over here, and then this column will let you import the file into R as variable LC. Okay, so the second one would try to a little bit reorder the LC just to check if it works, and just some data cleaning, not necessary absolutely. But the next one will actually assign the first row of data of this raw CSV. Let's open this again. So the first column will actually assign this gene name as the row name in RStudio, and the second one we are trying to remove the gene name from the matrix, because we do not want different data set into the same file. It causes confusion to the system. And the last one, we convert everything here into a matrix, which is that only will be able to store numeric text in this case. So once we are done with the preparation of the data, we actually run a log transform and we run a scaling before we throw everything into another variable called Y. So this, of course, it depends on the situation you are in and how do you want your data to look like. In different type of experiment, we'll have different type of scaling and normalization. Look for references, and if you need help, of course, you can email me or just leave a comment down below and I will try to reply when I can. So this is the data preparation on how do I prepare my data set to plot the data and stuff. And thanks for watching. Breakfast for living.